Now this augmented matrix looks a little bit different because the size is going to be different than some of the other ones because we only have 2 equations in our system, but we do have all 3 variables. So we're going to start the same way. We have 1, -1, 1, 9, and 6, 3, -3, 0. Okay, so we're going to go to our matrix. Oops. We're going to edit this guy. This time we have a 2 by 4. So we have 1, -1, 1, 9, 6, 3, -3, 0. And when I do the row reduced echelon form, I get 1, 0, 0, 3, 0, 1, -1, -6. All right, now if we look at the solutions here, I get x equals 3, but here I get y minus z equals -6. Now, both of these equations, they're both possible, right? Depending on what we pick for z. So this is going to have infinitely many ordered triples. And when that happens, you guys need to use set notation. So what we're going to have then is all the solutions, x, y, z, such that, and then you're going to go through and solve for each one at a time. So x, well, I already know x is 3. That's not going to change. Y equals, so I come up here and I'm going to add z to both sides. So y is just z minus 6. And z I have no information about. That's where you use the real number notation. So z is in the set of all real numbers. So epsilon and then all real numbers. For B, our augmented matrix is going to be 2, -2, -2, 2, 2, 3, 1, 2, 3, 2. There is no z term, so that's 0, and then the constant is also 0. So we need to change our matrix to a 3 by 4. And then once you guys have this, notice there's decimals. What you want to do is get in the habit of using your math fraction feature. So once you see the decimals, press math, and then there's your fraction feature. Press enter and enter again. So what we're actually going to write down here is 1, 0, -2 fifths, 0, 0, 1, 3 fifths, 0, and 0, 0, 0, 1. So we get x minus 2 fifths z equals 0. We have y plus 3 fifths z equals 0. And we have 0 equals 1. But we know 0 cannot be 1. So this system has no solution. So there's no x, y, or z that you can pick that's going to logistically make 0 equal 1 because that's never possible. And then what I want to do is I want to jump down to example C at the bottom left-hand corner. Okay, so kind of jump down there. And we're going to write the augmented matrix. Now notice this augmented matrix, we have 3 variables, but we have 4 rows. Okay, when you have more rows than you have variables to solve for, your bottom row is going to possibly be eliminated or going to create a no solution. So let's talk about what that looks like once we get it. So our augmented matrix is 2, 3, -1, 3, 1, -1, -1, 0, -1, 1, 1, 0, and then 1, 1, 3, 5. And then if we type this in, we're going to get, for edit, this time we're going to have a 4 by 4.
Right here?
Yeah, right there. Right there. And our 4 by 4 is going to be 2, 3, -1, 3, 1, negative 1, negative 1, 0, negative 1, 1, 1, 0, 1, 1, 3, 5. And when we do the augmented matrix, when we do the row reduced echelon form, we're going to do math fraction. And then we get this guy here, okay? So we have 1, 0, 0, 13 ninths, 0, 1, 0, 7 eighteenths, 0, 0, 1, 19 eighteenths, and 0, 0, 0, 0. So again, the issue that's coming up is this bottom row. All right, there's an extra row because we only have the 3 variables. So in the process of putting in this in the RREF form, it's going to create a bottom row with either all zeros or like a no solution situation. Okay, so we are going to ignore that last row. And so, so what we end up with is we have x and then equals 13 ninths. Oops. 13 ninths. Then we have y is 7 eighteenths. And we have z is 19 eighteenths.